By plotting the symmetrical bands of opposite polarity on a map and using fossils found on the seafloor, oceanographers are able to determine the age of the seafloor. This map shows the age of all ocean floors. The colors represent an expression of the seafloor spreading over the last 200 million years. The most recent ocean floor, or dated from the Pleistocene to the present age, is revealed in this burgundy color. And as you can see, that burgundy color is present right along the mid-ocean ridges and the East Pacific rise on the eastern side of the Pacific Basin. The older seafloor, here shown as a turquoise blue color, the late Jurassic between 144 and 161 millions of years ago, is detected far away from the mid-ocean ridges. Also note the relative symmetry of the Atlantic Ocean basin in contrast to the asymmetrical Pacific, where the spreading center, or the East Pacific rise, close to the eastern margin of the Pacific Ocean basin. The data on the paleomagnetism combined with data on the age of fossil can then determine the age of the seafloor. So for example, if you have sediment sample that was collected over here in the North Pacific, and you know that the symmetrical band of polarity runs all the way down to the South Atlantic, you know that that portion of the seafloor was created at the same time because of the spreading of the seafloor. Okay, likewise, here in the Pacific, if you collect a sediment sample here in the South Pacific, and you know that that band extends towards the North Pacific, you know that that location on the North Pacific will have the same age. So with that logic, you can map the age of the entire ocean floor. The fossil used to determine the age of the ocean floor are called foraminifera. That's actually an animal. It's a planktonic amoeba, which makes a shell, which you can see here. These shells remain in the sediment over millions of years. So when the animal dies, the shells sink to the ocean floor and accumulate on the ocean floor over millions and millions of years. Turns out that these shells come in a variety of forms and can be quite pretty. Sediment sampling can be done with a device called the piston core. So the core is tethered to the research vessel. It is lowered down all the way to the top of the ocean floor. As it reaches the top of the ocean floor, a messenger is released and triggers the insertion of the core into the sediment. So it gathers the sediment and takes it back aboard the research vessel in an undisturbed way. So you have your layers of sediment indicated here by the different shades of brown, and each of those layers will have a different distribution of the foraminifera. So this is what it looks like in the real life. This is a picture of a sediment core, and you can see the different bands of sediment, and each of those bands have different species of foraminifera, as you can see here in the picture. And so then by determining the age of these shells through a technique called carbon dating, scientists can determine the age of the seafloor. So as you go deeper in the sediment core, the older is your sediment.